All right, hi everyone. We are doing 9.3 today, which is talking about simplifying radicals. And the first bullet point up here is just talking about the product property of square roots, which essentially is just telling us that we can break things down into smaller components instead of just one large number. We're going to get into that in just a second. Okay, so when we're simplifying radicals, what we're trying to do is to get it down to prime numbers. So we look at a number like 72 and we could say 72 is what times what. So first thing I think of is 9 and 8. So it's 9 times 8. And we want to keep going until we have prime numbers. 9 is not prime. Remember, prime means that it can only be divisible by itself or 1. But 9 you can break down into 3 and 3. Now, what I do, and you don't have to, but what I do is I underline the prime numbers so I know that those are the ones that I'm trying to use later. So then we look at 8. 8 is 4 times 2. 2 is prime. And then 4 is 2 times 2, which are both prime. At this point, what we're trying to do is look for pairs. And any pairs that you have, you are going to circle and you're going to put outside of the radical. Okay, so what that means is 3 times 3 is really still talking about the square root of 9, which we know becomes 3. Okay, 2 times 2, square root of 4, which is just a 2, right? But then we have this lonely 2 that doesn't have a pair, and that one stays inside. So our final answer would be 3 times 2, which is 6, and then root 2. Okay, so essentially what's happening is any pairs go outside, any single prime numbers go on the inside. Anytime there's more than one, you just multiply them. Okay, so now we go into 192. Okay, now the big thing with these is do whatever you're comfortable with. For me, I'm going to divide it by 4, so it's going to be 4 times 48. Now you might not have noticed that. You might have just done 2. It doesn't matter how you break it down because you're always going to get down to the same prime numbers. Okay, so at this point, I know 4 is 2 times 2, which I'm going to underline because they're prime. And then 48 is 6 and 8. We have 6 and 8. 6 is not prime. It's 2 times 3. And then 8 is 2 times 4. And 4 goes all the way down to 2 and 2. Now this is the main reason why I underline it, just so that I know which numbers to use. You don't want to use the 4, 6, or 8 just because of the fact that those are already broken down further. So we're just looking for pairs. So we have 3 pairs of 2s. Now this is a very common mistake that students and even teachers make. 3 2s on the outside do not give me 6. It's 2 times 2 times 2, which is 8 for our final answer. On number 3, you can notice that there is something different. The main difference on this one is just that there is a number outside. You treat it the same way, but at the very end, we're going to tack on that 3 on the outside. So again, we're just going to look at 27. 7 is 3 times 9. So we have 3 times 3, and we look for pairs. Okay, so we have 1 pair of 3s and 1 lonely 3, which means we have 3 root 3. Right now, this is where we ought to tack that on the outside. Okay, the important part about this is a lot of us are going to think that we want to distribute it, which is true, but not in the case of the radical. We are just multiplying the things that are on the outside. You can only multiply common terms. So it's going to be 3 times 3 on the outside, which is 9. The root 3 stays root 3. You can only multiply square roots with other square roots. All right, so for the next one, you are able to break this down again. So I'm going to do 3 times 81. 3 is prime. 81, 9 times 9. 9 is 3 and 3. 9 is 3 and 3. So we have 2 pairs of 3s and then a lonely 3. So 3 times 3 on the outside, which is 9. And then a square root 3. Notice how that actually is the exact same thing that we just got for the last one. But keep in mind, we still have this little 1/3 out in front. So we need to multiply this by 1/3, which is the same thing as dividing by 3. So our final answer is 9 divided by 3, which is 3. Okay, now the difference on these ones are that you now have some variables. Sorry, I couldn't think of the word right now. So first off, we're going to break down the numbers. So 63, I know that it's divisible by 9. It's actually 9 times 7. 7 is prime. 9 is 3 and 3, right? So we have a pair of 3's, which goes outside, and a lonely 7 that goes inside. Now, normally that's our final answer, but this time we have this square, the square root of x to the 4th. Now, if you remember, x to the 4th means that you are multiplying x times x times x, right? X times itself 4 times, okay? So thinking about it the same way that we have been doing it is we write it out and then we circle our pairs. So we have 2 pairs of x's. So that means we have an x times an x on the outside. And if we have nothing left over, that means that there is no square root left. Kind of like when we have something like the square root of 4, right? You just have 2. You don't have 2 and then the square root of something, right? So we have x times x, which is the same thing as x squared. The only thing left to do is to combine these two answers. So we do everything on the outside, numbers, then variables. Then we do everything on the inside, numbers, then variables. On this next one, if we notice, we have the square root of 25, which maybe you see right away and you notice that it is a perfect square, so you know that that is just 5. Otherwise, maybe you decided to try and break it down. Well, if you notice, all you have is a pair of 5's, which means you have a 5 on the outside. Just like I was discussing in number 5, ironically, a bunch of 5's here, we just don't have a square root then anymore. It took the square root away. Okay, so now we have x's, right? X times x times x, right? We have a pair of x's, which means one of them is outside, and then we have a lonely x on the inside. Final thing is just to put them together. So we have 5x square root of x. Now, sometimes numbers get a little bit bigger, or your exponents do, so I want to focus on a pattern, and you can always write them all out and do the pairings like we just talked about with your variables, or if you notice, the square root of x to the 4th became x squared, okay? The big thing with these is that whatever the exponent is, what you're actually doing is dividing by 2. So square root of x to the 4th just becomes x squared. It gets a little tricky when you have ones like this, right? Not an even number, right? So what's happening here is you just rewrite it. So it is an even number and then 1 left over, right? So what we did is we just rewrote it. If you think about it, if you multiply these, you're back to where you started, right? So just like in the last one, when you have an even number, you just divide it by 2. So that's where this x came from. And we just had this leftover one. Okay, and we're going to do that trick on the next one. Again, if you want to write them all out and circle them and have the pairs, that's totally fine. It just gets a little bit crazy, like in number 7. In number 7, if you notice, there's the x to the 17th. So that's a lot of x's to have to count out and write out. So it'd be easier to have this trick, or this method perfected. Okay. So again, we're going to focus on the number first. Hopefully we can notice that 4, square root of 4 is 2. So we have 5 times 2 on the outside, right? Because we have a 5 in front. So that gives us 10. Okay, so that's part of our answer. I'm going to move on to this x to the 17th. Okay, just like I was discussing in number 6, what we're going to do is we're going to make that an even number by taking 1 away, right? This is actually the exact same thing. We're just pulling 1 away, and then now we're looking at something with an even power. Now I could write out 16 x's and circle a bunch of pairs, or all you do is divide it by 2. So this gives me x to the 8th, and then we have that 1 left over. Same thing as for, sorry, I want to underline this because it's the one we're going to use. Okay, part of our answer. Same thing for y to the 6th. Okay, this is already even, so what you can do is just divide by 2, and you get y to the 3rd. And then we have z to the 9th. So again, odd number. which means we're going to rewrite it so that 1 is by itself. So now it's even. Z to the 8th, all we have to do is divide by 2. So we have Z to the 4th with Z left over. So now this one's a little bit longer. We got to put them all together. So again, we're going to put everything on the outside number first. Then we're going to go in alphabetical order. So X to the 8th, Y to the 3rd, Z to the 4th. Now, if you don't go in alphabetical order, that's not technically incorrect. It's just the most mathematically correct. We try to do in alphabetical order. We talk about that a lot. Then we look at our square roots. We have a square root of X. We have no Y's underneath the square root, but we do have a square root of Z. And this would be our final answer. Okay. At this point, I encourage you to pause the video and try these two out before you continue. And then I'm going to go through these pretty fast so that you can check your work when you're done. So go ahead and pause, right? Pause the video and try these really quick. All right, so hopefully at this point you have looked at it a little bit on your own. So now I'm going to break these down and show you the answers. So we have 128. I'm going to divide that by 4. So it's 4 and 32. 4 is 2 times 2. 32 is 4 times 8. 4 is 2 times 2. 8 is 4 times 2. Whole bunch of 2's here. And 4 is 2 times 2. All right, so now we have a bunch of pairs. 1, 2, 3 pairs of 2's. Which again, remember, it's not 3 times 2. It's 2 times 2 times 2, which is 8 root 2. If you put 6, you just made that little mistake. It happens very often. Okay. So now I'm going to look at the square root of x to the 8th. It's even, so all we do is divide by 2, which gives me x to the 4th. Y to the 10th, same deal. All we're going to do is divide by 2, so we have y to the 5th, because it's even. And then the last one, square root of z to the 14th, same deal. Even number, so we're just going to divide by 2, which gives me z to the 7th. Sorry, that kind of looked like z to the z. All we have to do, put them together. 8, x to the 4th, y to the 5th, z to the 7th, square root of 2 as your final answer. And then we have our last one. We're going to take 96, and I'm going to divide it by 4 again. You could just do 2. But 4, which goes to 2 and 2. And it's actually 4 times 24. I'm going to do this as 3 and 8. 4 and 2. 2 and 2. Circle our pairs. 2 pairs of 2's, which gives me 4 on the outside. And then we have a 3 and a 2 on the inside, which we multiply for 6. Only issue with this is that we do need to account for this negative 2, which remember, only outside numbers. So we have negative 8 root 6. Moving on, we're going to talk about x to the 7th. Remember, when it's odd, we take 1 away. Oops, it would help if I took 1 away. Then we divide that 1 by 2, which would give me x to the 3rd with an x left over. Same thing with the y's. We have y to an odd number, so we take 1 away. Oh my gosh, z, what the heck? Sorry. Try this again. Then we divide the even one by 2, we just get y, and then the square root of y. Our final one, square root of z to the 4th, even, so we just divide by 2, z squared. Now we put it all together. We have negative 8, x to the 3rd, y, z squared, square root of 6, x, y. All right, hopefully we did pretty well on these last two. If we got a couple or a little bit off, that's okay. But hopefully we saw our mistakes and everything. So at this point, you can go ahead and go through the Microsoft Forms and turn that in, whether you do it through OneNote or copy and pasting it into Chrome. Remember, you need to use Chrome if you do use the internet for it, just because otherwise you won't be able to see pictures, or some of the formatting might be off. So make sure you take a look at it on there. All right, we'll talk to you soon. See you later. Bye.